Hello, Senior 1. This is the last exam of March 2019. Question 1. When a piece of copper, its temperature equals 150 Celsius, is thrown in a boiling water. Boiling water means that the temperature here is equal 100. Heat transfer copper to water due to the heat transfers from copper to water. Why? Because higher thermal energy of water. Water has thermal energy more than copper? Of course no. Higher temperature of copper than water. The temperature of copper more than water? Yes, this sentence is right. Question 2. Which of the following is used to measure the heat combustion of a certain fuel? Measuring the heat combustion by the pound calorimeter. Question 3. The opposite table shows the value of specific heat for substance at room temperature. Which of these substances takes the least possible time to be at 80 Celsius? Substance A, 0.385, substance B, 0.444, substance C, which is equal 0.711, and D equal 0.889. The largest specific heat is D, and the smallest specific heat is A. The question is, what of these substances take less time to be at 80 Celsius? Means that which of these substances be heated faster? The substance that heated faster, which have the smallest heat capacity. The smallest heat capacity, the fastest to be heated. So the answer is A. Question 4. If the separation energy of the ammonium nitrate salt in water equals 150 kJ, its hydration energy equal 120 kJ, and the separation energy of water equal 100 kJ. So the solution of this salt in water is what? And its delta H value equal what? To solve this question, we need to write the rule of delta H. Delta H equal H1 plus H2 minus H3. H1 is the separation energy of the solute, which means the separation energy of ammonium nitrate salt, which is 150 kJ, plus H2. H2 is the separation energy of the solvent, separation energy of water, which is equal 100, minus H3. H3 is the hydration energy, and the hydration energy here equal 120 kJ. So the total will be 130 kJ. 130 with a positive sign, not negative sign. Positive sign indicate endothermic. So the answer is D. Question 5. When drops of concentrated sulfuric acid that is H2SO4, are added to water, the temperature of water rises because the sum of two separation energies of the particles of each of solute and the solvents are higher than the hydration energy, means that H1 plus H2 bigger than H3. P. The sum of two separation energies of the particles of each of the solute and the solvent are lower than the hydration energy, means that H1 plus H2 smaller than H3. C. The separation energy of ions is higher than the hydration energy. And D. The separation energy of ion lower than the hydration energy. There is nothing about the separation energy of the ions here. So C and D cancelled. To know the answer, we should know that temperature rises mean that the reaction produce heat. Produce heat mean it's an exothermic reaction. And the exothermic reaction mean delta H equal negative value. And it's become a negative value by H1 plus H2 minus H3, which means that H1 plus H2 bigger than smaller than H3. Question 6. On dissolving 28 grams of potassium hydroxide, KOH, in water to form 1 liter of the solution, the temperature raised by 6.89 Celsius. What is the molar heat of the solution of potassium hydroxide? He need delta H. Okay, at the first we need to get the Q. Q equal mc delta T. The mass is 1. Why 1? Why not 28 grams? Because here we use the mass of the solution, not the mass of the solute only. The mass of the solution is 1 liter. 1 liter is 1 kilogram, equal 1 kilogram. Because the solution is diluted solution. Q equal mc delta T. M is 1 kilogram. C is 4.18. 4.18, it is a specific heat of water because the solution is diluted solution, which means that the solution can't be treated that it is an H2O, it's a water. And delta T is 6.89. To get the delta H naught equal negative Q over N. Negative Q, which is negative 1 times 4.18 times 6.89 over N. N is the number of mole. The number of mole here equal mass over molar mass. The mass of potassium hydroxide is 28 and the molar mass is 39 plus 1 plus 16. And the product 12Pa. Question 7. If the heat content of hydrogen bromide gas, HBr, is less than the heat content of the element forming it, this sentence means that the product is less than heat content of the reactant. What would be the thermochemical equation which represent the heat of formation of the hydrogen bromide gas? First one or the second or the third or fourth one? At first, is that an endothermic to say sentence A or sentence D, or this reaction is exothermic to say that the answer is P or C? How we can know? In the question said that the product is less than reactant. The H of the product is less than the H of reactant. So the reaction is exothermic. Exothermic means the delta H equal negative. So P may be right and C may be right. Which one of them is right? B. Why B? Because the condition of the thermochemical equation is the product must be equal 1 mole. And P is HBr, not 2 HBr, so it's only 1 mole. The sentence is P. Question 8. The opposite diagram represents the reaction of formation of HI, hydrogen iodide gas, from its constituent element. Which of the following represents the change in heat? Which company? This reaction. In the diagram, have H2 plus have iodine will produce HI. If this diagram is exothermic or endothermic, from the least energy or least heat content to high a heat content. So it is an endothermic. Endothermic means the delta H is positive. So the A sentence may be right and C sentence may be right. Here in the diagram, the product heat content, the H of the product is higher than the H of the reactant. So C sentence is the correct one. Question 9. From the following equations, equation 1, the formation of CO with delta H negative 110.3. And the second equation is formation of CO2 with delta H negative 393.5. Concluded that the molar enthalpy of CO2 higher than CO, or molar enthalpy of CO2 is lower than CO, or molar enthalpy of CO2 equal to CO, or molar enthalpy of CO and CO2 equals 0. At the first look, we can say that delta H, that is equal negative 393.5, is higher than negative 110.3. So the molar enthalpy of CO2 is higher than the molar enthalpy of CO. But it's a wrong answer. Why? To solve this, we can or we should use the Hess's law. The Hess's law, by subtracting the two equations, equation number 2 minus equation number 1, it will form CO plus have O2 equals CO2. And by making delta H1, delta H2 minus delta H1 will produce negative 283.2. Means that the delta H2 is larger than delta H1. So the product will be negative. The reactant here is CO and the product is CO2. So we can say that the formation of CO2 is lower than molar enthalpy of formation of CO gas. Question 10. In which of the following cases the quantity of absorbed heat is minimum? Absorbed heat means that the reaction is endothermic. Graph A is exothermic and graph B is endothermic. Graph C is exothermic and graph D is endothermic. So it may be P or D. What's the difference between graph B and graph D? The graph B, the distance between H of the reactant and H of the product is very, very large, which means it's a huge quantity of absorbed heat, maximum. And in graph D, the distance between H of the reactants and H of the product is very small, which means that it's a small amount of absorbed heat. So the absorbed heat here is a minimum. So the answer is graph D. Question 11. The following equation represents the decomposition of ammonia gas to its standard constituent element. 2NH3 produce N2 nitrogen gas plus 3H2 3 mole of hydrogen gas with delta H equal positive 92 kilojoule. Positive, which means that the reaction is endothermic. Conclude the thermochemical equation which represents the standard heat of formation of the ammonia. The thermochemical equation should be formation of ammonia, which means that nitrogen plus hydrogen will form ammonia NH3. And the second condition, thermochemical equation, the product should be NH3, just 1 mole. So, half nitrogen gas plus 3/2 hydrogen gas equal 1 mole of ammonia, NH3 gas. The delta H of formation of the ammonia will be negative 46 kilojoule per mole. How we got this? In the upper equation, the 2 NH3 was equal delta H equal positive 92. 2 moles equal positive 92. So 1 mole will be positive 92 over 2, so it will be equal negative 46 kilojoule. Question 12. The combustion of acetylene gas, C2H2, in excess of oxygen, releasing energy equal 1,299 kilojoule per mole. This is delta H. Okay, delta H with exothermic or endothermic reaction, releasing energy. So releasing energy means that the reaction is exothermic. What is the thermochemical equation? The answer is combustion of acetylene. The acetylene gas, C2H2 plus oxygen, equal carbon dioxide and water vapor. By making balancing to the reactant and making balancing to the product, so the thermochemical equation is balanced, delta H of the combustion will be equal 1,299 with a negative sign. Negative sign indicates that the reaction is exothermic. Question 13. A 100-gram metal object is placed in hot water. This object acquired a quantity of heat equal 100 calories. This is a Q. Calculate the change in this object temperature. We need delta T. Knowing that its specific heat equal 0.24 joule per gram dot Celsius. This means that it is a C. The solution is Q equal 100 calorie. To converting the calorie to joule, 100 times 4.18 because 1 calorie contains 4.18 joule. To find the delta T equal Q over MC from the equation of Q equal MC delta T. Okay, to find the delta T, Q, which is 418 over M, which is 100 gram, times C, which is 0.24. So the product will be 17.4 Celsius. Question 14. A sample of one of the illustrated substances in the opposite table, its mass is 5 grams, which means that M equal 5, is heated. Its temperature raised from 25.2 Celsius to 55.1 Celsius. We can get delta T from this by making T2 minus T1, 55.1 minus 25.2 Celsius. As a result of absorbing a quantity of heat equal 133 joule. This means that I know the Q equal 133 joule. Use the relation Q equal MC delta T to identify this substance. How can I identify this substance? X or Y or Z or W? By making the specific heat, or by get the specific heat, we can know the substance. Delta T equal 29.9 Celsius. And to find C equal Q over M delta T. Q equal 133 and M equal 5, delta T equal 25.9. 29.9, so C will be equal 0.889. So the substance is X. Question 15. In terms of the reaction, hydrazine plus oxygen producing 2 mole of water vapor plus nitrogen gas. Delta H equal negative 577 kilojoule. This means that this reaction is exothermic. Calculate the value of the average bond energy of N bond N in hydrazine molecule by knowing that the average bond energy is illustrated in the opposite table. In this table, illustrated that N bond H and O double bond O, N triple bond N, and O bond H. To find delta H equal energy of the breaking reactants bond minus energy of the formation products bond. By drawing every bond for each molecule, subtracting the formation product from the breaking reactant. And we will find that N bond N equal 157 kilojoule per mole. Question 16. Calculate the standard heat of formation of water by knowing the bond energy. And this table illustrated the bond of H bond H, O double bond O, OH bonded with each other. The solution is, let's make a thermochemical equation of formation of H2O. H2 plus half O2 will produce H2O. We should produce a 1 mole of water, just 1 mole. So the delta H of the formation will be H product minus H reactant. The heat content of H2O, O bonded with H and O bonded with H, minus the reactant, which are H bonded with H and O bonded with O times half. So the product will be 239 kilojoule per mole. Question 17. Calculate delta H of 2 mole of CO producing C plus CO2 by using these two equations. To solve this equation, we must use Hess's law. By adding the two equations, C plus CO2 plus H2O plus HO, forming 2CO plus H2 plus H2O. By cancelling H2O and H2O, H2 and H2, the equation will be C plus CO2 forming 2CO2. This is the inverse of the equation, if you notice. And to get the delta H, it will be the delta H1 plus delta H2, positive 131 plus positive 41. It will be 172 kilojoule. And we notice that it is the inverse of the normal equation of the original equation. So we will make an inversion. This inversion will be 2CO producing C plus CO2. It's not a formation here, it's a decomposition. And delta H here will be the inverse of delta H before. That make the positive 172 will be negative 172 kilojoule. Thanks for listening.